Hello, welcome back to Learn Physics. In today's topic, we are continuing with our magnetism and matter. Okay. In last video, we finished till our magnetic elements, isn't it? In Earth, that is dip, the inclination and horizontal component of magnetic field. That much we learned. Today we are going to study about some of the important terms used in magnetism. So terms used in magnetism. Okay, so here we are going to study about the terms used in magnetism. First one is magnetic field strength. Magnetic field strength. It is represented with capital letter B. It's a vector quantity. It is represented as B. Okay. So to explain this, we are first starting with the Lorentz force, which we learned in the last chapter. What is Lorentz force? F is equal to electric and magnetic together. Here we are taking only the magnetic force component, that is Q into V cross B. Okay, from this we can give a definition for magnetic field strength B, that is F is equal to Q into V cross B, that is QVB sin theta. So if I am taking that if Q equals 1 coulomb, V equals 1 meter per second and theta equals 90 degree, then what will be F? F will be equal to B. So this one, if I am writing it as a sentence, it will become the definition for magnetic field strength. That is, if 1 coulomb of charges flowing through a material with a velocity of 1 meter per second and which is perpendicular to the magnetic field, which both are perpendicular to each other, then this V and B are perpendicular to each other, then the force acting will be, or force acting on the material will be equal to the magnetic field strength. Okay, so if 1 coulomb of charges flowing through a material which has which is moving with a velocity of 1 meter per second, and the magnetic field is, the velocity is the charge which is moving with the velocity of 1 meter per second and which is perpendicular to the magnetic field. It is perpendicular to the magnetic field, then the force acting on the material will be equal to the magnetic field strength. Okay, so in another words also we can say, depending on the magnetic field lines, number of magnetic field lines, we will call it as magnetic flux, isn't it? Magnetic flux per unit area, that is called as, that also called as unit area is called as magnetic field strength. Flux is phi is equal to B dot A, isn't it? So what is B dot A? B A cos theta, and if theta equals 0 degree and A equals 1 meter square, then we can say number of magnetic field lines passing through the conductor will be equal to the magnetic field. Phi will be equal to B. In that way also we can define, or this way also we can. Any one definition you should remember. Okay, so if 1 coulomb of charges passing through the material with a velocity of 1 meter per second and which is moving perpendicular to the magnetic field, then the force acting on the material is called as magnetic field strength. Okay, so and or we can write it as number of magnetic field lines passing per unit area. In unit area, if we are considering, what will, how many number of magnetic field lines are passing, that is called as magnetic field strength. Clear? So what is the unit of magnetic field strength? Unit of magnetic field strength is Tesla we will say. Okay, it is represented as T. And number of magnetic field lines. See, phi equals B dot A, BA cos theta. Phi representation is Weber. So Weber per meter square also we can say. Weber per meter square. WB per meter square. This is another unit of magnetic field strength. Okay, clear? So this is, these terms used in magnetism are very important. Any one dimensional formula or definition or SI unit, any one question, surely it will ask from this part. Okay, so clear for you? Now the second one, which is magnetizing force. Magnetizing force. It is represented by the symbol H. This also a vector quantity. Okay, so what is meant by the magnetizing force? It is the degree to which a magnetic material can magnetize another material. That means, suppose the magnet is here, north-south pole. This magnet can magnetize another magnetic material. How much it can magnetize? How much this magnet can magnetize this material? That ability, that how much it can magnetize, that degree is represented as magnetizing force. So it is the degree to which a magnet can magnetize any magnetic material. The degree to which any magnet can magnetize a material, magnetic material, that is called as magnetizing force. It is represented by H. Okay, so formula is B equals mu 0 into H. This is the formula for finding out the magnetizing material force. Okay, so this is the relation connecting these two. How we are coming to this conclusion B equals mu 0 into H? So we know the solenoid. What is the formula for magnetic field of a solenoid? That is mu 0 into Ni. This Ni is called as H. That is magnetizing force. So that is the number of ampere turns of the solenoid of unit length. How many number of turns, ampere turns are there for a toroidal solenoid which is having unit length? Okay, so the number of ampere turns of a toroidal solenoid having unit length is called as magnetizing force. So any one definition you can say. So magnetizing force is the ability or degree to which, how much they can, this magnet can magnetize another magnetic material. That is called as this magnetizing force. That is H is equal to N into I. Okay, so the number of ampere turns of a magnetic material having unit length. For a solenoid, while we are considering a solenoid, this is called a magnetizing material. Okay, so what will be the unit of this H? So the unit of H is number of ampere turns per unit length, isn't it? So ampere is current is ampere per unit length, that is per meter. So ampere per meter. This is the unit of magnetizing force. Now we are going to find out the dimension. What will be the dimension? Ampere means ampere only. It is a basic unit, isn't it? So meter means L to the power minus 1. So the rest everything will be 0. So M L to the power minus 1, T to the power 0, ampere to the power plus 1. This will be the dimension of magnetizing force. Okay, so clear this. Now the third one is magnetic permeability. Permeability. What is meant by the magnetic permeability. See, magnetic field strength and magnetizing force, we told it for the magnet, isn't it? The ability of the magnet to magnetize another material, and it is the strength of the field strength. Because of the magnet, it is getting that field strength, isn't it? So here this magnetic permeability is for a magnetic material. It is not for the magnetic material. How the degree to which or extent to which the magnetic material will pass the magnetic field lines through it. How much it can allow to come inside the material. How much the magnetic material can, how many magnetic field lines can enter inside the magnetic material. That is called as magnetic permeability. It is the degree to which the magnetic material will allow the magnetic field lines to enter into it or pass through it. That is called a magnetic permeability. Permeability means permitting the magnetic field lines to come inside. What is that degree or up to which extent it can happen? Okay, that is called a magnetic permeability. Okay, so magnetic permeability is represented by the letter mu. Mu equals. So we already learned about the field strength and magnetizing force, isn't it? So B by H. This is called a mu. Okay, so mu magnetic permeability equals B by H. So what will be the unit for this one? B, what is the unit? B is Tesla. And H, what is the unit? Ampere per meter. Isn't it? So it is Tesla ampere to the power minus 1 meter. This will be the this unit for this magnetic permeability. Okay, or see, we know magnetic material having this magnetic field strength has another unit called a Weber per meter square, isn't it? Weber per meter square divided by ampere per meter. So what we can do? Weber per meter square into 1 by ampere per meter, taking the reciprocal and multiplying. So we will get it as, so Weber ampere to the power minus 1 meter to the power plus 1, it will become minus 1. So this is another unit of this. These two are the units of permeability. Okay, so what will be the dimension of permeability? So these are all are important questions, so that's why I am telling it in detail. Okay, what will be the dimension of B divided, permeability dimension will be dimension of B divided by dimension of H. For that we first need the dimension of, actually while we are calculating this one we will get it as mLT to the power minus 2 into ampere power minus 2 we will get. This is the this is the dimension for permeability. Okay, like that you can remember. But so how we are getting this one is, first you should find out the magnetic dimension of B. B, how we can find out? F divided by QV. What is the dimension of F? M L T to the power minus 2. Dimension of Q is I into T. Isn't it? I is equal to Q by T. So dimension of Q is I into T. A into T into L T to the power minus 1. Okay, so we will get it as L and L will get cancelled. M T to the power minus 2. Here T and T will get cancelled. So and A to the power minus 1. Like that we will get. Now if we are considering B by H, M T to the power minus 2, A to the power minus 1 divided by H is ampere per meter. Ampere per meter. So ampere L to the power minus 1. So this ampere, while we are considering the top, M L T to the power minus 2, A to the power minus 2. Like that we will get. Okay, so it is easy. If you know the values, you can just substitute and find out. That's all. So B equals mu by H, that one you should know, and you will be getting the dimension of mu also. So this is permeability. In permeability itself, we have permeability of free space as well as the permeability of relative permeability is there. So relative permeability means mu r. It is represented as mu r. So what is this relative permeability? It is mu divided by mu 0. What is this mu? Relative permeability is written as mu divided by mu 0. What is this mu? Permeability of a material. Okay, permeability of a material, or we can write it as it is the permeability of a material to the permeability of free space. That is called as relative permeability. Relative permeability is permeability of material divided by permeability of free space. What is magnetic permeability? It is the degree to which the magnetic material is done. It is allowing the magnetic lines of force to come inside. Okay, that is called a magnetic permeability. So relative permeability is mu by mu 0. Or in another way we can write it as relative permeability is B by B0. Like that also we can write. What is B? B is the number of magnetic field lines per unit area. Isn't it? That is when we learned about magnetic field strength, phi by A. That one, phi is equal to B dot A. So phi by A we learnt. Isn't it? So it is the magnetic field strength per unit, number of magnetic field lines per unit area in a material to the number of field lines per unit area in free space. B by, what is B? B is the number of magnetic field lines entering to a surface in unit area. That is B. If it is considering for a material or divided by that free space, number of field lines passing through a material in free space, that ratio is also called as magnetic relative permeability. Okay, so mu is the magnetic permeability, mu, and mu r relative permeability equals mu by mu 0, and mu 0 is the permeability of free space. Okay, so all these things you should learn properly, and the units and dimensions also, that is very important. Okay, so next is intensity of magnetization. Intensity of magnetization. So what is meant by this intensity of magnetization? It is the magnetic moment per unit volume. That is called as intensity of magnetization. That is represented as I. I is the representation for intensity of magnetization, that is magnetic moment per unit volume. That is magnetic moment is represented by M divided by V. What is magnetization? Unit is, how we can represent the unit? Magnetic moment is ampere meter square divided by meter cube. So we will get it as ampere meter to the power minus 1. So this is the unit of intensity of magnetization, magnetic moment per unit area. So magnetic moment and all already we learned them into one pole strength into distance between the two poles, isn't it? So that is magnetic moment. So magnetic moment per unit volume is written as intensity of magnetization. So what will be the dimension for this one? Dimension for this one is, so M to the power 0, ampere is there, L to the power minus 1, per meter means L to the power minus 1 is there, T to the power 0, ampere to the power plus 1. So this will be the dimension of intensity of magnetization. Okay, clear? So now one more term is there, that is magnetic susceptibility. Magnetic susceptibility. What is meant by this magnetic susceptibility? It is represented by chi M. Chi M is represented as magnetic susceptibility. Magnetic susceptibility is the ratio of intensity of magnetization to the magnetizing force. I is the intensity of the magnetization. Magnetic force is represented as H. So I by H. This is magnetic susceptibility. It is the ratio of intensity of magnetization to the magnetizing force. So we know what is intensity of magnetization. It is magnetic moment per unit volume. So what is magnetizing force? N into I. So both the terms per unit length, isn't it? So if both the terms while we are considering, here magnetizing force also, what is the unit? It is ampere per meter. Isn't it? Here also the unit is ampere per meter. So what will be the unit of chi-m? Chi-m has no unit and it has no dimension. Dimension also not there for it. Okay, so clear? So chi-m is the magnetic susceptibility. It is the ratio of intensity of magnetization to the magnetizing force. Okay, it has no unit and dimension also not there. So you understood all these terms which is used in the magnetization. So in next we will be studying about the relation connecting all those things and the diamagnetic, paramagnetic and ferromagnetic substances. For that we require all these terms then and there. Okay, so clear for you? Field strength is represented by B. Magnetic permeability is represented by mu. There also we learned about the relative magnetic permeability also. Okay, I think all these are clear for you. Okay, so I am winding up for today, and if you like the channel, please don't forget to subscribe. Okay, thank you for watching. Bye.